How's it going, Algebra 1? We are going to pump the brakes on learning substitution for a second. It's given us a lot of trouble, and so I think we need to learn something else first before we go back and try to relearn substitution because, yeah, it's just not going great, and that's okay. Let's look at these things called literal equations, literally. Okay, literal equations are equations that consist mostly of variables. They're just letters, and there's barely any numbers involved. So it really comes down to you knowing your fundamentals and knowing your algebraic fundamentals to solve some problems and solve for certain things. We're going to talk about that for a little bit, okay? So why is this important? Like I said, we got algebraic solving fundamentals that we need to get under our belt. It's going to be useful for substitution later on because you're not always dealing with just numbers with substitution. So for example, I want us to get to the point where we can look at this and then I can say, all right, I want you to solve for y for this equation. Okay, what do I mean by solve for y? What do I mean by solve for anything? Well, what I mean by that is it's getting the variable by itself. It's solving for it. We want y to be by itself. So yeah, I want you to get to the point where you can look at 5x minus 3y equals 15 and just know exactly what you're going to do without even really thinking about it too much. This is basically a standard form equation, but even this is a literal equation. We've been actually solving literal equations this whole time without even maybe fully realizing it. And obviously you could see, I mean, that's part of what we are doing with standard form. Okay, so let's pump the brakes and let's look at some stuff. You're going to have to take some notes, and then I will give you a note sheet that'll actually help you with the literal equations. But before we do that, I have this chart for you, okay? Think of these next couple things as tools in like a toolkit right now, okay? Obviously they're notes, and not a lot of people like notes, but again, they're useful for something to refer to when you don't know what to do next. One of the big things with literal equations is using reverse PEMDAS. Now, PEMDAS has been learned in middle school. It is our order of operations. It tells us how to tackle math problems in any given expression. And so what we want to do is we actually want to do the reverse PEMDAS when it comes to algebraic solving. The reason is we rely a lot on opposites in order to undo things on one side. But then when I do that to that thing, I got to do it to the other because it's an equation. I need to make sure it's equal, right? So the most basic example I can give of that, why we do it to both sides, is 3 equals 3. But as soon as I do this, that is no longer true. So I have to do it to both sides to make it true. So whatever you do to one side of the equation, it has an effect on the other one, and you need to consider that, okay? Well, let's run through this. So PEMDAS is an acronym. It stands for parentheses, exponents, multiplication, division, addition, and subtraction. So the reverse of that is SABMEP. Okay? So here are all the actions that happen, and these are the opposite actions. These are the opposite actions that we are really going to rely on. Okay? This is probably the most important thing in terms of algebraic solving, is opposite actions. Okay? So here's some examples. We are going to solve for x. Using x and y. We're going to solve for x with these examples. So we're going to get x by itself. Okay? So let's see what we do first. So if I have something that's being subtracted, again, the opposite is to add. So we're going to add y. And what I do to one side, that's a horrible color, you can't even see that. I'm going to add y here. And what I do to one side, I have to do to the other. So to solve for this, it would be x is equal to 1 plus y. Okay, is what we would get. If we have x plus y equals 1, the opposite of adding y is to subtract y. So it's the same thing I did up here, except this time I'm just subtracting y. And so I get x is equal to, I'm going to run out of room, x is equal to 1 minus y. Okay, we'll circle that, and we'll circle that. Okay. Now, if you have something where you're dividing x divided by y, first of all, you're never going to see division written like that ever again. Like, you will probably never see that again. So what we do is we actually use, it kind of looks like a fraction, right? Because division and fractions are actually the same exact thing. So this is x divided by y equals 1, and the opposite of dividing is to multiply. So I got to multiply both sides by y. When I do this, the y's will cancel on this side, and I'll be left with x is equal to 1 times y, so 1y. And there we go. We've been solving for x, right? X is getting by itself. We are solving for x. Let's keep going. This is x times y is equal to 1. Again, you're going to see this way more than you're going to see this or even that, okay? Instead of using those symbols, we put them next to each other. All right. So x times y equals 1. I got to divide both sides by y because, well, that's the opposite of multiplying by y. These y's cancel, and I'm left with x is equal to 1 divided by y. That's what x is equal to. Okay. And finally, let's look at exponents. The opposite action is the nth root. So let me describe that to you. If I have something that is x to the nth power, then the opposite would be to actually take something to the nth root, just like that. Now, typically, the most common thing we do, and these would end up canceling, the most common thing we do is a square root. That is to the second root right there, okay? So if I have something that is x squared, well, I got to take the square root of both sides. And when I do this, my x is going to equal the square root of y. And the square root and the square, they will cancel out. If this was cubed, I could do the cubed root, right? I could do the cubed root of x cubed. The 3's would cancel out. I'd be left with just x. Okay. Now, parentheses is kind of an oddball, because we don't actually have an opposite for that. What you would do is, if you have something, and let's say you have something like x plus y, it's in parentheses, but then you got this other crap out here, right? What you'd want to do is you'd want to get rid of the minus 3 and the multiplied 1/2 first, and then look at this again and then go through SADMEP, right? So now you're like, all right, I want to get x by itself. So the opposite would be to, subtract y, just like I did up here. So it's basically everything else, but now it's in parentheses, okay? So do everything else around parentheses first, and then once you're just left with your parentheses, go back through and be like, all right, am I multiplying these in here? Am I dividing? Am I adding? Use your opposites once again, okay? Couple other fundamentals before we move forward. Here's a big one. This one is combining like terms. Combining like terms is something that we still struggle with, okay? Let's re-jog our memory. So terms are numbers, variables, or they're both together, okay? So like you could have like 2x or 5y squared. They're just a combination of those things, and they're separated by addition and subtraction. So for example, if I look at this example down here, I have 1, 2, 3, 4, 5. I have 5 terms, okay? They are separated by addition and subtraction. Now, like terms have the same variables and exponents, okay? And that means I can combine them through addition and subtraction. So if I look at this guy, I notice, all right, I got 2x right here. I also have 3x, positive 3x right there. I can add them together. 2x plus 3x gives me 5x, right? And then I look at my 5y, okay, 5y, and then negative 2y, or minus 2y. I got to keep the sign there. So I know I'm going to do 5 minus 2. I will get 3y, and that would be a plus 3y because we have a positive 3. And then finally, this guy, negative x squared. Why didn't I combine them with the 2x and the 3x? Again, they have different exponents, so I have to just leave them as minus x squared. And that is as simplified as I can get, okay? And sometimes you got to do that when you're working with equations. Make it easier on yourself. Make it look nicer, okay? You won't run into confusion. Look at the distributive property, okay? Distributive property, I just use symbols. I think this is better than just like a clear definition because I can show it. If I have something that is a times in parentheses b plus c, well, that's going to turn into a times b plus a times c. Okay? I'm distributing the a, I'm multiplying the a to both parts. Okay? And that's what I come up with. So if I see it with this example, right, I am multiplying, so I need to keep my signs in mind. All right? So for example, if I do negative 3 is on the outside, I'm going to multiply it to both terms in here. Negative 3 times a is just negative 3a. Remember, like we said, if two things are next to each other, they are being multiplied. That shows me they are being multiplied. Now, the next one is negative 3 times negative 5. We can actually multiply that. We know what 3 times 5 is. It's 15. Is it positive or negative? Well, it's a negative times a negative, so that's a positive 15. And that guy is done. That guy is simplified. Okay? And then lastly, let's look at our last skill, which is removing multiplied fractions. Okay? If you have something like 1/4 times x, and you want to get rid of that 1/4, what you need to do is you need to multiply both sides of the equal sign, by the reciprocal of this fraction. A reciprocal is just a flipped fraction. Okay, it's a fancy word. So if I wanted to get the reciprocal of 1/4, that is 4 over 1. I flip it, and it's telling me I got to multiply both sides by that reciprocal. If I have a whole number or anything like this that's not in a fraction, I can turn it into a fraction just by putting it over 1. Okay, and so this is going to cancel over here. They're opposites, it turns out, because you'll get 4 over 4, which reduces to 1. And so you get x is equal to 20 over 1, which is just 20. There we go. Anytime you want to get rid of a fraction like that. Okay? All right, now let's shift some gears. Let's actually look at some literal equations, right? Now that we have some of the fundamentals down with your notes. All right, literal equations. So we have these two equations right off the start. They actually look very, very similar to each other. Okay. Okay, to solve these, let's use reverse PEMDAS. Okay, so I'm doing SADMEP. So I'm going to take care of what I'm subtracting or adding first. Oh, I'm subtracting this 5. So what's the opposite? Add 5. What I do to one side, I do to the other. Keep this true. So then these 5s will cancel. I'll be left with 2x is equal to 13 plus 5, which is 18. Now I go to multiplication division. I am multiplying by 2. The opposite is to divide by 2. And I do it to both sides. And so I will end up getting x is equal to 18 divided by 2, which is 9. Just like that. Let's look at this. Okay, we're going to solve the equation for x. All right, that means we're going to get x by itself. Just like we did here. We solved for x right here too. Okay. All right, same thing. What's the opposite of minus b? Subtracting b? I got to add b. I'm left with ax is equal to, well, I can't do it like I did with 13 plus 5. We know 13 plus 5 is 18. C plus b, they're not like terms. I can't combine them. So I have to write them like this. C plus b. And that's fine, okay? And the last thing I got to do is I got to divide everything by a. I got to divide both sides by a, because I'm multiplying by a. And so those will cancel. I'll be left with x is equal to c plus b divided by a. All right? So what are some similarities and difference between these two equations? Well, obviously this one isn't using any numbers at all. Okay? It's not using numbers, and that's really the only difference. Everything else is pretty much the same exact process we just did. We just can't combine like terms because, well, we just went over why you can't do that. Okay. Let's look at some actual problems now. Let's look at some one-step problems and practice using SADMEP. Okay. Now, one-step problems, as the name implies, there's one step to solving these, and you will get them all. Let's do the ones that are circled. So I'm solving for w right here. So I want to get w by itself. So to get rid of this L, which is multiplying the w, Sing. What's the opposite of multiplying by L? Dividing by L. So the L's will cancel here. I'll be left with A divided by L equals W. And that guy is solved for W. We're done. We don't have to do anything else. Okay? Let's look at something like this. I equals PRT. All right? I want to solve for T. Well, if I look, now I have P times R times T. Well, what I could do is, I know P times R. Well, couldn't I just divide by T times R? I could. I could just do that. I could just divide both sides by P times R. And I will end up getting the PRs on that side to cancel. Now I'll be left with I divided by PR is equal to T. You can do that. Okay? They are all being multiplied together, so if you just pick out the parts that you need to divide by, it's just like we did over here with L. Okay? We had to pick out the L. Let's look at number 6. We have A is equal to pi r squared. We want to solve for r. Well, I want to get r by itself. I'm going to use SADMAP. Well, before I get my exponent done, I have to get rid of what I'm multiplying. I'm multiplying by pi. The opposite is to divide by pi. So I divide by pi. These cancel, and I get A divided by pi is equal to r squared. Now, while we're doing this, and it's occurring to me, this is not a one-step problem. We're going to need 2 steps to do it. It's a liar. This is a liar. That's okay. We'll fix the liar. We have r squared. I want to undo the squared. So remember, using our sheet, the opposite of squaring something is to square root it. So then the 2 and the square root will actually cancel. And I'll be left with r is equal to the square root of A divided by pi. And that guy's done. All right, let's look at 7 and 8. 7, we want to solve for C. We got to get C by itself. I got to get rid of this minus S. So the opposite is to add S. The S's on that side will cancel, they're opposites. I get left with M plus S equals C. We're done. That is everything we need to do for that. Okay? And let's look at number 8. We got D equals M divided by B. I am solving for M. Alright, I got to get M by itself. How do I get rid of that divide by V? Oh, I got to multiply by V. That's the opposite. So I multiply both sides by V. So I get, after these V's canceled, I get left with dV, D times B, right, they're multiplying, equals M. I'm done with that one. Cool. Those are one-step equations. We had to use reverse PEMDAS, but it's going to get even more apparent as we turn the page and we look at multi-step equations, multi-step problems, right? But those are the basics. It's solving for the variable, getting that variable by itself. Let's look here, okay? And it'll give you some helpful hints, right? So thinking backwards of PEMDAS, we've already been doing that, removing fractions with the reciprocal. We're probably going to need to do that. And then the last step is usually, keyword usually, to divide by whatever is next to the variable. We'll see if that ends up working out, okay? Again, let's do the ones that are circled. Number 10, we have V equals, I'm going to rewrite it, V equals 1/3 times B times H. I'm going to solve for B. All right, let's think. I want to get rid of what I'm multiplying by. I'm multiplying this 1/3 and this H. Let's just start with the 1/3 for right now. I don't have to do it all at once. How do I undo a fraction? Well, I got to multiply both sides by its reciprocal. I got to multiply both sides by 3/1. Okay, so the 1/3 and the 3/1, they will cancel because they're opposites. We will be left with 3/1, which is just 3. So 3 times V equals, well, B times H. And then we want B by itself. To get rid of the multiplied H, I need to divide by H to both sides. And I will end up getting 3V divided by H is equal to B. Nice. All right, let's look at number 11. Okay, first of all, this is divide by 2. Okay, what do we do first? Are we going to tackle the divide by 2? Are we going to tackle the multiply first? What does SADMAP tell us to do? SAD-MEP, let's see. SAD-MEP tells us to get rid of division first and then multiplication. Now, these are together, so it actually really it doesn't matter too much in general. But for this problem, let's think about it for a second. That whole right side, all of it, is divided by 2. That means if I try to, really undo something over here, well, I got this divide by 2 I got to deal with. What I would do first is I would actually get rid of the divide by 2. Okay? How do you do that? Multiply. Multiply both sides by 2. That's the opposite. So I end up getting these 2's canceling. I get 2k is equal to m times v squared. Again, we're trying to get m by itself. So I have this v squared I'm multiplying by. I actually don't need to undo the exponent. There's really no reason to do it. The only reason we did it here was because we wanted to solve for r, and r just happened to be squared. Not the case here. Not the case here with m. So I can actually divide, because I'm multiplying v squared, I can divide both sides by v squared. V squareds here, they cancel, their opposites. I get left with 2k divided by v squared is equal to m. And there we go. M is solved for. Okay. Let's look at 12. We got a is equal to b plus c divided by d. All right. Well, all right. Let's look at our SAD-MEP again. Well, SAD-MEP, it tells us to get rid of what we're subtracting or adding first. Again, we kind of run into the same problem we ran into over here. I have this divide by d thing. It's dividing the b and the c. Okay. So maybe what we can do, in order to keep doing what SAD-MEP is telling us to do, I can consider that. Maybe I can rewrite this as a is equal to b divided by d plus c divided by d. I'm allowed to do that. They're both being divided by d, which now, even though I'm working with fractions, makes it really nice because, hey, I'm trying to solve for b. So what do I do first? Well, SAD-MEP tells me undo addition subtraction first. So the opposite of adding CD is to subtract CD from both sides. And so I get a minus c divided by d is equal to b divided by d. Kind of running out of room. Well, the last thing I got to do is get b by itself. I got to multiply. I got to multiply both sides by d. Now, here's where things get a little tricky. This problem's really weird. This is a great problem. The d's are going to cancel over here, which is awesome. B is going to end up equaling. We have d times this entire side. I'm not just multiplying by a. I'm not just multiplying the d to the a. I'm multiplying the d to everything. In fact, I'll make this more pronounced. So now, what does this look like? Well, this looks like our distributive property, right? I got to take this d, I got to multiply it to the a, and I got to multiply it to the negative c divided by d. Let's do that. So I get d times a, and then it's going to be minus, because it's a positive times a negative, minus d times c over d. So that's like d over 1 times c over d. Okay, so if I multiplied those, I would get d times c divided by d. Well, look at this. We have d divided by d. That's fine, but those are opposites. D times c, okay, divide by d, those are opposites. They cancel, and so I'm left with just minus c when everything is all said and done. Right? So using our distributive property, knowing about our opposites, we can simplify that to look a lot cleaner than just dc over d. Okay? Let's look at 14. Now, if you've been in my class last semester, and now at the beginning of this semester, you've seen this guy. You must be pretty well acquainted. This is standard form. We're solving for y. Wonder what it's going to look like. I just wonder, okay? So in your notes, I've showed you how to do this, but now we can think about it with SAD-MEP, right? I got to get rid of what I'm adding or subtracting first, but I want to get y by itself. technically this AX is adding, because I could rewrite it like this. I could rewrite this as BY plus AX is equal to C. Now it's a little bit more clear. Now I can actually subtract the AX. I know for sure I got to subtract the AX, right? I do it to both sides. AX's cancel. I'm left with BY is equal to C minus AX. And now in your next step, what was my next step? The next step was to divide everything by B originally in the standard form notes. However, again, using SADMAP, I know I got to divide by B. I'm going to go ahead, I'm going to divide both sides by B. I'm dividing the whole thing. So I get Y is equal to C minus AX divided by B. And you're looking at that and you're like, dude, I thought we were supposed to get Y equals MX plus B out of that, Mr. Knight. What's going on? It is in Y equals MX plus B. It just looks like crap. Seriously, it does. What I ended up doing is when you have Y is equal to the C minus AX, I'll put the B right here. So we're at that second step right here. When I divide everything by B, when I divide both sides by B, remember, if I'm dividing the whole thing by B, everything is divided by B. So what ends up happening is these B's cancel. I'm left with Y equals, and it should be Y equals MX plus B. My MX is this term right here, A over B X, minus, it would be Y equals MX plus B. So that B would be this C divided by B. Okay. And so this A over B right here, this is our M, and this is our B, our Y-intercept B. I just want to make that clear. These B's are not the same thing. They are not. They are just symbols, but there's a clear difference between them. When you do C divided by that B, whatever's next to that Y, you end up getting your Y-intercept. Okay. So they're the same thing. They just look like crap. Okay. Take my word for it.